In this video, we're going to be looking at definite integral properties. All right, and I believe there's about 8 properties that you have to know about definite integrals, and some of them you already know how to do. You just didn't know that you knew them. All right, so that we got to make them formal. We got to justify them. All right. So what's the objective for this video? Evaluate integrals using the properties of integrals. So here we go. Let's look at some visuals before we begin. So let's pretend this one I had done before in a previous video. If I had asked you to integrate the function 5 from 3 to 7, so I'm going to start from 3 here all the way to 7. And how do you graph y equals 5? Well, that's going to be a horizontal line at 5. So here's my horizontal line. It's a blue line here. And I want to integrate it from 3 to 5. So what is the area from there to there? So some of you can say, sir, that's a geometry problem. So what's the distance from here to here? Well, from 3 to 7 will be a distance of 4, right? And this is going to have a height of 5. So what's 4 times 5? It's going to give me 20. So that was kind of easy, right? And what you need to understand, that there's a property out there that says if you're ever just given a constant, it's just going to be the constant times b minus a, which is the bound. Okay. The next part, we're going to be looking at the integral here of 5 dx plus 7 dx. So I'm going to be adding this piece plus this piece. And what happens is, if I don't know, I think I messed up. It should have been 5x or something like that. It says that if you have 2 pieces, you can actually just make it one big piece. So, but I kind of messed up. This is what I'm trying to say on number 3. Okay, so on this one, I guess it's just justifying this one property again. So this could be really 5 times 4, while this one can really be 7 times 2. And I add those. So 20 plus 14 is 34. So all they did was I did the property, okay, instead of integrating. So now on this one, it says if you are given a function here and you're given another function, but if you notice the bounds are going to be from 0 to 2 of the function, and then I'm going to add it to something. It ends here at 2, but it's going to continue at 2. So let's pretend it was from 2 to what? 2 to 8 in this case of my function. So instead of doing 2 pieces, I cannot just say, because it's the same function and they have this endpoints together, I could have actually just done from 0 to 8 of the function f of x dx. Now, I didn't do it in this problem, but I'm just, showing you the fundamental theorem of calculus again, which is a prerequisite for the properties. So now, here are the 8 properties you need to know. The integral from a to a of any function is going to be said to be 0. Okay, now here's what I'm talking about. What is the area from 2 to 3? Well, here is going to be 1, whatever my height is, right? So it's 1 times my height. Now what if I ask you, what is the area from 2 to 2? Well, if I go from 2 to 2, it has no width. So if it has no width, it's going to be 0, and 0 times the height is going to be 0. So there's no width. All right. Now, property number 2 says that if I change my bounds, I have b and an a there. If I change them around to an a and a b, all I'm going to do is I'm going to change my sign of my integral. That's all it says. If I reverse them. So if I said the integral from 2 to 3 of f of x dx is 12, and what's the integral from 3 to 2 of f of x dx? And the answer will be negative 12. Okay? It says here, if I'm given a function that is always above the x-axis, then the area, the integral, is going to be positive. Okay? That's all it's saying, because I have a function that's above the x-axis. Now the next one says this: if I have a function that is always above this other function, then the integral of the top function will be greater than the integral of the bottom function, because it's above it, right? And we look at the next one. Now here's property number 5 is the one that we use. If I am given any number, just of any number, and I integrate it, you're just going to take that number and multiply it times the top bound minus the bottom bound. And this is the first example that we did. Okay, Number 6, what happens is, number 6 is a great property that I love to use. And if you're given any number, instead of leaving it inside the function, you can take it out, forget about it, find the integral, and then once you get the integral, you multiply it times that constant, rather than having it inside and messing that up. So what am I saying by something like that? For example, let me show you. What if I had the integral of 3x squared from 1 to 2? Okay, so in this scenario, let's well, I don't want to use, let's use 8 here. If I had this, I'm going to end up with 8x cubed over 3 from 1 to 2. When I plug in the 2, I'm going to get 8 times 8 over 3 minus 8 times 1 over 3. And that's going to give me 64 minus 8 is going to be 56 over 3. I hope I didn't make a mistake in there somewhere. Okay. Now, what the other one is saying is this 8, I can take it outside. And I can say 8, the integral from 1 to 2 of x squared. So if I was to integrate that, I'm going to end up with x cubed over 3 from 1 to 2. Plug in the 2, you're going to end up with 8 thirds minus 1/3, which is going to give me 7/3. Now, what did I have with this 8 here? I put it in the front, and 8 times 7/3 is 56 thirds. Sometimes it's going to be easier to just put the number outside and forget about it. Okay. Now here, this one says that if you're given a function, basically saying that if you have more than one term, you can break it up into each integral, and that's what we do. So if I was to give you something like the integral from 3 to 7 of x squared plus 3x plus 1, what we're doing is we're doing the integral of each piece, and that's the property that allows me to do that. Okay, and then here comes number 8, and number 8 is the one I really love to test on the exam, because students always, they always look at number 8 and they say, it's not very important. And yes, it is. Okay, what it's saying on number 8, it says that if I have a function, let me say I have a function here from 3 to 7 of any function dx, I can actually break this up into any pieces. So for example, I can say I can go from the integral from 3 to 5 of f of x dx plus the integral from 5 to 7 f of x dx. So if I can break it apart, that means that I can put it back together again, and that's what this property says. Okay. So let's look at some examples here. This one, a very simple problem here, is going to be 10 times 5 minus 2. 5 minus 2 is 3 times 10. The answer is 30, and I'm done. Okay. Oops, I have the same problem over here twice. So on this one, let's integrate this one. I'm going to end up with 2x. Property number 7 says I can do each piece by itself. 4x to the 4th over 4 from 0 to 1. These 4 actually reduce here. So now I'm going to plug in a 1, and I'm going to end up with 2 times 1 plus 1 to the 4th. And then I'm going to go minus 2 times 0 plus 0 to the 4th. And then all of this is a big fat 0. So I'm going to end up with 2 plus 1. My answer is 3. And now these are the ones that I love to test. The integral from 2 to 7 of f of x dx is 23. The integral from 7 to 10 of f of x dx is 23. What is the integral from 2 to 10? Well, if the area from 2 to 7 is 23 and from 7 to 10 is 23, then what's the area from 2 to 10? The area from 2 to 10 will be 46. So this is 46. What is the integral from 10 to 2? Well, it's going to be negative 46. Remember, if I change the bound, you just change the sign of your integral. Okay. Now here is the hardest one that students have trouble with, right? If I tell you that the area, the integral from 0 to 4, is going to give me an integral of 12. So what I do is it's positive 12, so I included up here 12. And then they tell me that the integral from 2 to 4 is from 2 to 4 is negative 3. So I'm going to include this down here, negative 3. So the two pieces here, the piece from here to here, this piece plus this piece has to give me this big piece. So this piece plus negative 3 has to give me the 12. So what is the integral from 0 to 2? The integral from 0 to 2 has to be 15 because the two smaller pieces have to give me the big piece. Okay? All right, here's some more. Finding each integral. Sometimes you're going to be able to look at the integrals. I'm going to be applying the fundamental theorem of calculus. What's the integral from 0 to 4? Here is 0, here is 4. Basically, what I'm going to do is I'm going to use geometry. I'm not going to use anything else. My base is 4, my height is 4. 4 times 4 is 16 divided by 2, it's 8. And now, what's going to happen is the answer is going to be negative. Why negative? Because it's below the x-axis. What's the integral from 6 to 10? Here is 6 and here is 10. And I notice that this piece and this piece are the same. So they're going to actually cancel each other out. So my answer is going to be 0. What is the integral from 6 to 4? So here is 6 and here is 4. So that means that that piece is 2 and that is 4. So I'm going to have an area of 8. Now, is it positive 8 or negative 8? And some are going to say, sir, the answer is negative because it's below the x-axis. Yes, but if you notice, it's from 6 to 4. It's backwards. So the answer is going to be positive 8. Now, if I had asked the integral from 4 to 6 of f of x dx, then this one would be negative 8. We always read from left to right. And finally, what's the integral from 0 to 10? The integral from 0 to 10 would be from here all the way to here. But I know that this piece here and this piece here are going to reduce, so I just really need to find this integral here. So we said that was 2 times 4 is 8, and that was another 8 over here, so 8 plus 8 is 16, but it's below the x-axis, it's going to be negative 16. All right? Now, here's the last one, the last slide that I'm going to be working on. Tell me, is my integral positive or is my integral negative? From 0 to 4.75, about right there, would you say it's positive or negative? So I'm going to look at this versus this, and I notice that there's more on the bottom here than there is on top, so my answer is going to be negative. What about from 1.6 all the way to let's see, this is 1.6, it's going to be from that all the way to 4.75. Well, from here to here is going to be below, it is negative. What about from 1.6 to 7.8? And 7.8 is over here. So I'm going to notice that this guy is larger than this guy. So it's going to be positive. And what about from 3? From 3 to 5.5. So let me find my 3 first. My 3 is going to be right here. And 5.5 is going to be, this is 5. 5.5 is going to be here. So I'm going to be looking at this versus this. And guess what I noticed? There's more on the bottom than above, so my answer will be negative. Okay? And that concludes my properties video.